graphing in transformational form. So there's slope-intercept form, there's standard form, there's different formats of writing equations. And as you get higher into the mathematics, you'll find that there's a similar way we use to graph all of them. Okay? They all pretty much change and move or transform in the same way, regardless of what kind of function it is. Now, we're going to be focusing on linear straight lines today, but the same thing can be applied for all these different functions here, all the different shapes and sizes that you'll find in later in this class, and then in pre-calculus and calculus. They all move and translate and stretch in the same way. You kind of saw some of this in geometry. You did reflections, rotations, translations, and things like that. So it's not completely new, but it falls along that idea. Most of what you'll be focusing on today is translations. By looking at the equation, how does the graph move up or down, left or right? Okay? And a little bit on some stretching. Okay? You saw these in Algebra 1 when you did parabolas. We graph things in a certain way. Okay? But just take a look at all these. And focus on where the dot is and how that corresponds, that dot, to the equation. So what's the location of this dot, right? That's x equals 2, positive 2. Notice how the equation is x minus 2. Same thing here as well. Well, this thing right here as well. This is that x equals negative 3. Notice how the equation is x plus 3. So there are some patterns here. And from there, you can see, well, this would just be 0. And if we needed to, we can write a plus 0 minus 0 here as well. So there is a pattern, and that's the pattern you're going to use to graph. And when we change this to be x squared, or x to the, everything raised to the third power, it's just going to be a different shape. The idea that it can move one way or another based upon a plus or a minus will still be the same. All right. Now we have a similar idea that, well, what if we have, start here, right here, this is y equals positive 2, right? Starting 0, up 1, up 2. Notice how the equation is y minus 2. This is y equals negative 4, right? This is y plus 4. So in summary, you could probably say that the graphs are use the equations, but in an opposite nature. So if you have a minus 2, it really moves the graph 2 to the right. If you have a plus 3, it really moves the graph 3 to the left. It's kind of counterintuitive. If the y is minus 2, it moves the graph 2 up. If it is plus 4, it moves the graph 4 down. So somewhat counterintuitive, but it's the same pattern in all of these. Okay, if we put it together, we can move the graph down to the right 4, but also down 2. So this actually goes through the coordinate 4, comma. Wait for it. There you go. Positive 4, comma, negative 2. That's what the coordinate is right there. So by looking at this equation and how it's written, we can find out exactly where it goes through. Okay. Same thing over here. Let me move it over a little bit. There we go. We can see that this is a minus 4, so it's going to go through positive 4, comma, and this is plus 2, so it's going to go through negative 2. So we always have the opposite signs. Right? That's the takeaway here. It moves the opposite direction you might think it would. And then you might remember some of this from Algebra 1 when we were graphing absolute value and parabolas, the same thing happened. Now, you can see that all these have the same slope, but now this one's a little bit steeper, and that there's a number right here. So the slope still operates the same way, up 4 over 1, up 4 over 1. Okay. All right, don't have the whiteboard. So can we follow this pattern that as the number here changes, it just moves in the opposite direction, right? And the y, of course, translates it up and down. And if it is on the x, it will translate it left and right. Now that actual number numerically referred to it as k, and for the x is h. That's something we'll be using a whole lot today, but it's something that will come into play later on. Okay. All right. Same thing, just left and right. All right. So with that in mind, let's go ahead and there we go. Practice a few. So let's see here. This will go through the point. Which point will this go through? Yeah, let's look at that. Based on the notes and where to look. So we have -5 here, and we have -3 here, which means +5 and +3. So go ahead and plot that point, 5, 3. Starting at 0, 0, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. Right. Our vertical stretch, which is usually whatever's in front of the x, is called a vertical stretch. There's a special name for a vertical stretch when you're graphing a straight line, a linear graph. It's called slope. That's what you're familiar with. So in this context today, just think of vertical stretch as the same as slope. But when we start doing, like parabolas and things like that, we call it a vertical stretch, and it's not a slope because there's no rise over run. So that's why we're kind of getting used to that generic term as opposed to using slope right now. Right, and then with that information, you can go ahead and graph it. Right, it's going to be up 1 over 2, 1 over 2. You can also go the other direction. Good idea to use a straight edge when possible. There we go. And let's go ahead and figure out the y-intercept. Now the y-intercept is going to be, well, you already know what slope-intercept form is. What we're going to do is convert this to slope-intercept form. So you want to take this original equation here, and that's really slow. There we go. Get y minus 3 equals, now I'm going to distribute this, right? 1/2 times x, 1/2 times -5. There we go. And we could use decimals here, but in general, it's probably a good idea to leave it as fractions. It's more exact. So when you get 1/2 of 5, you can just write it as -5/2, as opposed to actually getting a decimal and putting 2.5 or something. And then from here, to simply get whatever's on the left-hand side out of there. So we have y equals. Our goal is to have y equals, right? So here we got y equals. 1/2 x. And -5/2 plus 3 is going to equal. Punch that in your calculator if you need to see what you get. Give you a second. That way you get used to using the fraction button on your calculator if you need to. Otherwise, just do the common denominators and get your number. All right. And it should come out to, I think, 1/2. If I'm not mistaken. There we go. So our y-intercept would be this number, whichever comes out, 0, 1/2. All right, so there you go. A few more. There will be some other variations, but this is the gist of it. So gather, let's see here. We got a -4 right here, and we have a +1 right here. What coordinate would that place us at? Okay, so yep, I'm always going to put the opposite sign as well. So I'm going to put +4, and I'm going to put the -1. Yeah. So that's going to start us at 4, -1. 1, 2, 3, 4, and then down 1. So we know our line goes through here for sure. Hey, what kind of stretch or slope is it? Yep. So we can use 2 or 2/1. That helps. It's not a fraction. And then go ahead and find the line. Right? So we did step 1. We can go ahead and graph it. So from our starting point here, go up 2/1. There it goes. Okay. There we go. I can go ahead and solve. So we got y plus 1 is going to be 2x, 2 times x, and 2 times -4. Subtract the 1 to both sides, putting it in slope-intercept form. So we got the y equals, and now we know our y-intercept comes from this calculation right here, -8 minus 1 minus 9, which we can confirm on the graph right here. That's at 0, -9. There we go. Yep. Yeah, the y-intercept is always going to be 0 because it's on the y-axis. So every single one of these points on the y-axis is 0, something. So it goes out saying that if you're finding a y-intercept, right, it's always going to be 0, something. Well, yeah, so it's going to be kind of like yesterday right now. If we go past number 3, what if I give you the graph, can you work backwards? So we want to look, given any information, be able to find, like on number 4, can we work backwards? So from here, yeah, the slope-intercept form, we could probably figure out just by looking at it, because we can see here, what's the y-intercept here? 1, 2, 3. That's at 0, 3. And what's the slope for this line on number 4? We can go up 1, 2, 3. And then it goes to the right 1, 2, 3, 4, 5, 6. So that makes the slope or the vertical stretch equal to 3/6, which is 1/2. So if we have this, and we know this, Can you write the y-intercept form? What would it be? And look back at the previous problem, see what you see. See what you get. Yeah, so the vertical stretch was always right here, right? And the y-intercept on this one, which is 0, -9, it was always right there. So you just want to work backwards and say, well, if I have a -9 here, I know it's 0, -9. Right? So if we have a 0, 3 here, I know it's going to end with, +3. Just go in the other direction. And if we have a slope of 1/2, I know we're going to have a 1/2 x here. What's that? Yeah, so let's pick a point. What point do we want to use? Like right here. So this one is 6, 6. All right. So what would the transformational form be with +6, +6? Yep, perfect. Y -6 equals 1/2, and in parentheses, x -6. So you see what we did first on 1, 2, 3 is now the last because we're working backwards. So this point would be 6, 6. There we go. All right, so to put that all together, right? Just reversing everything we did before. And we're starting with these types of graphs because it's familiar. We know about slope. We know, the coordinate system. We know slope-intercept form very well. But then we'll take this to the next level when we start looking at all these other types of functions, and they'll move the exact same way. The only difference with everything we're going to do down the line is that this might be to the second power, and it's a parabola. Or maybe instead of parentheses, it's absolute value, and it's going to be V-shaped. Or this could be to the -1 power. Could be an inverse function, right? So there's lots of different things we can use this for, but the idea that it moves the same direction with the -6 and the -6 is what we're getting at, establishing that pattern. All right, good. Let's see here. Do you want to try one more, or do we feel comfortable? All right, I'll just go through one more, just in case. If not, let's go ahead and work quietly on your own. So I can see a y-intercept right here. 1, 2, 3, 4, 5. Oh. And I can figure out that vertical stretch or the slope, right? So down 1, 2, 3 over 1, 2, 3, 4. So it's down 3 over 4. Down 3 over 4. I just got a mistake. Did you guys see it? Yeah, just didn't want to tell me. Yeah, it's -5. Thanks for that. We usually don't put the negative on the bottom of a fraction. It's technically correct, but no one writes it that way. So yeah, either negative would be on the top or in the front, but negative never on the bottom, really. All right, good. And what point do we want to use here? You'll notice we have a few to choose from. I mean, there's different points here. So which one do you want to go with? -4, 1, 2, 3, 4, and down 2. So -4, comma -2. So I'll write that one. So we got y is going to be +2, good, equals, and then x +4. Yeah, very good. And here's the kicker. What if I did a different one? What if I did, down here? And I did, what's 1, 2, 3, 4, +4, and then 1, 2, 3, 4, 5, 6, 7, 8. So what if I did +4, -8? Then I'd have this. All right? Which one's correct? Yeah, they both are, right? We use the exact same rules. We just picked a different point. And how can you prove they're both correct? Yeah, if we solve both of these, you get the exact same number. Right? And if we did it over here, right, so if we do -8, -8, get the -5. To do -2, we'll get the -5. So you get the same answer regardless of which method you use. So this is very useful because before it's like you had to have the y-intercept, you had to have the y-intercept, you couldn't do anything about the y-intercept. This method shows us that hey, you can use any point and you have the equation of the line. No longer are you tied to having a y-intercept to graph anything. And that's a very different way of looking at it, is that we don't have to have a y-intercept to graph. All right, very good, very good. All right, so I'll leave it at that. Practice on a few, check with each other, make sure you got it down, and then you can go home feeling like you got this under your belt. Okay. Tomorrow we'll review piecewise functions. We'll be using some decimals.